Okay, welcome to physics today. We have a few questions about work and energy, which is good because work is kind of hard. So if you think about work, first of all, we have our box here and we have our hand and we move the box up 5 meters. Do we do work on that? Yeah, I do work on this, right? Because I'm forcing on the box, the force of the hand, and I force over a distance that's parallel. So I do work. So work of U equals the weight of the box times 5 meters. And we could call that a positive work if you want, because we're self-centered and we think that we're positive, right? So what we do should be positive. But what else is happening at the same time? Gravity. So the force of gravity is also working on this. So the work that gravity does would be the weight of the object times 5. The only thing is, this weight was the magnitude of force I put on, but it didn't include the direction. It would actually be opposite in direction. Because the weight is the same as the force of gravity. So the force in my hand, if I called that positive, what do I have to call this? Negative. So the work of gravity then is negative 5W. Now you guys know that we don't have a real negative as far as direction for energy. But what happens is, all the time I'm working on this box, the Earth is working on it in the opposite direction, or it's a retarding work. So the net work done here would be equal to 0. But, commonly I ask, what kind of work did you do? And then this would be your answer. Okay? So if we look back at our question here, well, I guess before we leave this, let's say that I force on this box a little bit harder than 5. So let's say that in this same question, I'm going to do the weight of the box plus another 5 newtons, okay, over a distance of 5 meters. So now what's going to happen is, well, first of all, this is going to change, right? So this is not going to be 5W, it's going to be 5W plus 25. Do you agree? Where Earth is still going to be doing that same negative 5. So now I can say that I actually have a net work here that's equal to 25 joules. Okay, so what does that mean for the box? What kind of energy does the box have now? Well, it's got a change in potential that's gone up, which that really had nothing to do with the work since it got canceled out by Earth. What else does it have? What? Change in kinetic that is equal to 25 joules. Because that was what's left over here after the positive and the negative network was done. So now I could say, I've got a velocity here, right? I can say 25 equals 1/2 mv squared, and I could find a velocity of the box. So that's what's called the net work kinetic energy theorem. Okay, so if you have a change in kinetic energy, then a net work was done on the system. It is in the notes, but we haven't talked about it in class yet today. So with that said, let's look back at this problem and work on that. Okay, so back at the problem. What's going to happen here is this box is going to be accelerated up the ramp, right? I'm going to have a change in height due to, there's going to be a change in gravity, right? Potential energy due to gravity. Now, is that going to be considered net work? No, because the whole time that it moves up, that force up is going to be at least partially canceled out by the force down. So if we're just talking about the change in energy due to height above the ground, that will have nothing to do with the network, okay? But does that have to do with the work that M2 does on M1? Yes, right? Because the work that M2 does is equal to on M1, well, it's going to have to lift it up, this delta H. So it's going to be equal to the change in potential of M1. Because what else would be working on it? Well, the Earth is, but that's not what the question is. The question asks, what does M2 do on M1 to work on it? So it's going to be equal to that, and it's going to be equal to the change in kinetic energy of M1 as well. Is there anything else? This is where it becomes a little, maybe even a little more difficult, but is there anything else? Is there any other work that M2 is doing on M1, or that M1, yeah, M2 is doing on M1? Is there any other work? Well, what's happening here then, is my question, if you said no to that? Friction. So there's more to this equation. Okay, oh, I put an equal sign here, but that should have been plus. Okay. And then also plus the work of friction that M1 is encountering. Because if M2 wasn't pulling on M1, there'd be no friction. If there's no friction, you know, it's going to be taking away from our kinetic energy, right? But it still is work that M2 is doing on M1, and then that work from M1 is transferred into the surfaces of M1 and the ramp, to the random motion of the particles. So this is the work that M2 does on M1. Okay? So, so these are the numbers then, unless I mess that all up. But the work then that M2 does on M1 is, okay, so we've come up with this is the work that M2 is doing on M1, 6.7133 joules. Now another way that we could think about this, and it's actually easier, is thinking about the force that M2 puts on M1. So we know that work is force parallel to displacement. Work in this case would be signified as, well, the mass here is tugging on this rope, and through that rope it's tugging on M2. So the tension force is the summation of forces, or well, the tension force is the force that M2 is putting on M1. So we could just say tension, and that is parallel to 0.25. So the work then would be, tension was 26.845, which we got out of that first problem when we were doing acceleration of the system, times 0.25, and you'll find that we get the same answer this way. I just liked going through the other way so we could see where all the energies were located. So those are two ways to figure out the work that M2 did on M1. Now the question is, why does my answer key then have the wrong answer? Well, it looks like we had the right acceleration, so we did that correctly, but this here is kind of where we messed up on the answer key, and that could have been just so we had this discussion. I like to pick on this problem because there's a lot of little idiosyncrasies with it. So, do you have any other questions?